So, one second. Okay, so today we're going to be talking about multiplying and factoring polynomials and quadratics. So the first thing that we need to do is figure out, well, what is a polynomial, right? So according to the definition, a polynomial is an expression that has more than two terms. Okay, so if you're being more specific, it's usually the sum of multiple terms that contain different powers of the same variable. Okay, I'll say that again because that was kind of a lot. It's the sum of multiple terms that contain different powers of the same variable. So in this example here, if I can figure out how
10x to the seventh is a polynomial?
Yeah, so this right,
all three of them basically makes sense.
This would be one. Why isn't it?
Great.
Okay, hold on, my screen is frozen. Okay. Okay. Okay, yeah, okay. Can you guys see that now?
Yes.
Okay, perfect. So, in this example here, 10x to the 7th is going to be the first term, 9x to the 5th is going to be your second term, or negative 9x to the 5th will be your second term, 15x to the 3rd would be a third term, 9x would be another, and 3 would be another. Okay, so these all have different powers of x, and this one has no x, but it's also considered a term. So that's why this is called a polynomial, because there are multiple terms and they all have different powers of x. Okay, any questions about that?
So 9x could be 9x to the power of 1.
Yes. Yes. So this is to the power of 1, but it's unnecessary to write that, but you can if you want. It means the same thing. How do I have a mouse if I'm on a mobile? I'm on an iPad, and it's this app, and it has like a pointer thing. I don't know how to explain it. Okay. So now we're going to talk about what a monomial is. So a monomial is an algebraic expression that only contains one term. So it would be like one of these things. So an example of that would be 10y to the 14th, because it's just one term. Another example could be like 8y or like 3x. These are all monomials because they only contain.
3?
What?
But what about 3?
3? Yeah. Actually, no, because I think it has to have, let me look it up one second. I think it has to have a variable in it to be a monomial. But if polynomials have one, like a section or a term without a variable, it's still considered part of the polynomial. Does that make sense?
Yeah, because I guess x could be 0.
Yeah, x could be 0. Let's see. A monomial includes numbers and variables multiplied together. So I guess technically 0x could be, but you would have to make sure to write the 0x, and like you'd make sure to write the variable in front of it. Okay. So pretty probably self-explanatory, but a binomial is an algebraic expression that contains two terms, or like two powers of a variable. So like this would be 3y squared plus 4y, because this is the first term and this would be the second term. And then 16a to the 4th minus 8. This would be the first term and this would be the second term. Okay, does that make sense? Because in a binomial, you can also have As long as you have one of the terms has a variable, this would also be considered part of the binomial. Okay. Two terms, binomial. One term, monomial. More than two, polynomial. Okay? Okay.
So there could be a never-ending sequence with all of them where
Yeah.
have powers in it, so it can be unended, so you would never solve it.
Yes, that's actually possible. It could be a never-ending sequence and it would, or like a never-ending expression, it would still be considered a polynomial. Yes, do you have a question?
Why are they all finishing by nominal?
By what?
Nominal, not nomials.
Because that's the definition of the suffix. The suffix. Like,
Okay.
it just means like a term. The suffix nomial means like a term. Or I think it might be a root word. I don't know that much English, but when you say like nomial, that just means like a term. So polynomial means like multiple terms. Binomial means two terms, and monomial, because mono means one, so then monomial would be just one term. Okay. Any other questions? Okay, so now we're going to talk about multiplying binomials together. So when we multiply binomials together, the way that we're going to do it is by using distributive property. So in this example here, we're multiplying x plus 2 times x plus 3. Okay, so to do this, as I said, we use distributive property. So we're going to distribute this set of parentheses out to this set of parentheses. So what we're going to do is have x plus 2 times this x from here. And then we're going to have x plus 2 because we're distributing the entire x plus 2 parentheses times this 3. So think of it as like this is a first one like term, and then these are separate. So you're doing this times this and this times this. Okay, so that's what this is. Okay, so then we distribute that out. So x times x plus x times 2, which is what you see here. And then 3 times x plus 3 times 2, which is what you see here. Okay? And then you multiply that.
2x plus 2x plus 3x plus 6.
Yeah. So when you multiply that out, you have x times x is x squared. X times 2 is 2x. X times 3 is 3x. And 2 times 3 is 6. Okay, so then simplify that further, and you just add these two x's together because we can combine like terms. Remember when we talked about combining like terms? Since we have this right here and they're the same variable and the same power of the same variable, we can just add them together. So we have x squared plus 5x plus 6. Okay?
You add like 5x plus 2x to the power of 2.
No, because we can't, we don't know what x is.
Yeah, so because they're different powers of x, so this is x squared, so you have an x times x right here, but here is just one x, so 5 times x. So that means they're not like terms because they're different powers. So this is power to the power of 2, and this is to the power of 1. So that's why you can't add them together. But here, this one is to the power of 1, and this one is also to the power of 1, so you can add them together. Does that make sense? Okay. So what you end up with is x plus 2 times x plus 3 equals x squared plus 5x plus 6. And then that's how you multiply binomials. Okay, so of course I'm going to make you guys do a practice one. So go ahead and try this one, and we'll go over it in some time.
It's pretty complicated though.
Yeah, here I can put up this example and you guys can follow that. Okay, I'll give you guys like 1 more minute.
Can you give me a minute to write the answer in the chat?
Yeah. Okay, we're gonna go over it. Does anybody want to explain how they did it?
Can I do it?
Who was that?
Athena.
Yeah, go ahead.
So I did x plus 3, so then it's like x times x, so I simplified it, so it's x times x plus x times 3 plus x times 4 plus 3 times 4, which equals x squared plus 3x plus 4x plus 12. And then you add the 3 and 4, which equals x to the power of 2 plus 7x plus 12.
Yep. Good job. Let me just write this out so that you guys can see it and write it down. If you did not get that, let me write this step out too, because I think it's really important to see how you're distributing it. Okay. So yeah, she's 100% right. The first thing you're gonna do is figure out how you want to distribute it. I like to just take the first term and then distribute it out with the second set of parentheses. So you have x plus 3 times x and x plus 3 times 4. Then when you distribute that out, you get x times x plus x times 3, 4 times x plus 4 times 3. Multiply those out, you get x squared plus 3x plus 4x plus 12. Simplify that, you get x squared plus 7x plus 12. Any questions? Okay, awesome. So now we're going to be talking about binomial special products. So there are 3 main special products when you are learning about multiplying binomials, and basically what they are, special products just basically means shortcuts. So you don't have to use the distributive property. So if you see a problem in one of these 3 forms that I'm about to talk about, you can see the first one up right now. But if you see a problem in one of those forms, you can just use a shortcut and you don't have to go through all of the whole distributive property, and you can find the answer with the shortcut. Okay, so the first one is when you multiply a plus b by a minus b, the answer is your a squared minus b squared. So this is just the general form, no numbers. It's just like, let's say a is x and b is 2, and you have x plus 2 times x minus 2, your answer would be x squared minus 2 squared, which is x squared minus 4. Okay, so here's like the distributive property kind of proving this little shortcut. So when you go through using distributive property, you have a plus b, and then you're going to distribute this set of parentheses. So you have a plus b times a, and a plus b times negative b, because of the negative sign right here. Then you distribute that out, a times a plus a times b, and then a times negative b and b times negative b.
So what's the shortcut?
The shortcut is that when you see a problem in this form, you know that the answer is just a squared minus b squared, and you don't have to go through all of this work right here to get to a squared minus b squared. So for an example, let's say that your problem is to multiply c plus 5 times c minus 5.
C squared plus minus, 25.
Yeah, exactly. Because
Basically
of
5
the short,
squared. C
squared minus
5 squared.
5 squared, because if you look back at the general form right here, you see that c, can you see that c is a and 5 is b, so a squared minus b squared is going to be your answer. And since your a is c, you have c squared, and since your b is 5, you have 5 squared. So c squared minus 5 squared, and you simplify that and you have c squared minus 25, like that. Okay, any questions on the first product? I want you guys to write this example problem down, because there's no practice problem with it. Actually, I'm gonna make you guys do a practice problem. Okay, Let's do. Okay, I want you guys to write out the product for this using this shortcut. I don't want you guys to use the entire distributive property unless you absolutely need to. I'll give you guys like 1.5 minutes. Thirty more seconds. Okay, who wants to tell us what they got as their answer?
Can I?
Let's see if anyone else wants to do it. Otherwise, you can do it. Anybody else? Okay, go ahead.
So since on the other example problem, you get c squared, so it should be a squared, and then 5 to the power of 5 equal, 5 to the power of 2, I mean, equals 25, so it's a squared minus 25.
Awesome. Okay. Any questions on that one? Okay, let's move on to the second one. So the second one is when you multiply a plus b times a plus b or a plus b squared. What you get is a squared plus 2ab plus b squared. Okay, so here's the distributive property for that. A plus b times a plus b. Then you take this parentheses and distribute out this one. So a plus b times
Is there any
a.
shortcut on this?
Yep, this is a shortcut right here. A plus b times a plus b equals a squared plus 2ab plus b squared. Okay. So multiply it out. I like showing these proofs so that you guys can see how this shortcut works, because it's important to understand why it works, not just that it works. Okay, so distribute out your second set of parentheses and you get a times a plus a times b plus a times b plus b times b. Okay, so a times a is a squared, a times b is ab, a times b is ab, and b times b is b squared. Okay, so if you guys notice, you have AB right here and AB right here. And since they're the same thing, you can just group them and you have two of them. So that's that one.
How are we going to do it in question?
Like this, okay? So if you have m plus 7, m plus 7 squared is m plus 7 times m plus 7.
So it's
Do you agree?
basically 7 squared and then m squared and then 7 plus 7 equals 14m.
Yeah, exactly. That's exactly right. So looking back at our general form, we have A equals M from our A right here, and B equals 7. Oh, sorry. From our A right here, and B equals 7 from our B right there. So since the general form of when we multiply this out is A squared plus 2AB plus B squared, we have A squared equals M squared, 2AB, A times B, M times 7 is 7M. Then you multiply that times 2, that's 14M, right? And then B squared is 7 squared, and 7 squared is 49. So that's how you get that M plus 7 whole squared, like M plus 7 in parentheses squared, is M squared plus 14M plus 49. Okay?
Are we going to do a practice problem?
Yes, we are. Okay, so for your practice problem, I want you guys to do x plus 3 squared. And I want you guys to use this shortcut right here to solve it. I'll give you guys 2 minutes. 2 minutes. This one's a bit harder. One more minute.
Wait, where is the problem? Okay.
This is a problem. X plus 3 squared. Okay, does anyone want to explain?
Can I?
Yes, 1 second. Just want to make sure that nobody else wants to do this. Everyone can have a chance. Does anyone else want to explain? Okay, go ahead, Athena.
So x squared is x squared, and 3 plus 3 equals 6, so it's 6x, and then 3 squared is 3 squared, which is 9. So it is x squared plus 6x plus 9.
Okay, perfect. Good job. Give me 1 second.
I just had to remember the question.
Yeah. Okay, now we're going to move on to the third one. So this one is a minus b squared. So a minus b times a minus b. So when you do that,
it's just minus.
Yeah, so it's basically the same one above, except instead of plus 2ab, you're going to get a minus 2ab. Okay, so again, here's the proof, or like how to see that that's true. Distribute then distribute out your A, distribute out your negative B, A times A, negative B times A
What
times
if-
negative B.
They asked you, what if A was 250 or like 1,000 or 1,000,000 or 1
If they gave you that big of a
1,000,000.55?
number, they would be required to give you a calculator to solve that one.
Okay.
Okay. So then you get a squared minus ab plus b squared, and negative ab minus ab is negative 2ab. So that's how you get you're subtracting 2ab instead of adding 2ab. Here's an example of that. A minus 3 squared. A is a in this case, and b is 3. So a squared is a squared. 2ab. A times b is 3 times a, which is 3a, times 2 is 6a, and 3 squared is 9, or b squared is 3 squared, which is 9.
Is there going to be a Kahoot today?
Probably not, but definitely next week, because next week is the last class. Okay. So, and then we have a squared minus 2ab. We found that 2ab is 6a, so minus 6a plus 9. Okay. Any questions before I give you guys your practice problem?
No.
Okay.
Wait, hold on. I still don't really get why is it like two this 2ab?
Okay. Good question. So if you look here at where I multiplied it out, do you get this part until right here where it says a times a plus negative b times a
I'm pretty
plus a
sure
times negative
it's basically if the number b was, let's say, 6, it'd be 6 plus 6 equals 12, and then b. So basically 12b plus b, 12 or something.
Yeah, but why is his question? So I'm gonna explain that. So do you see how we distributed it out right here?
Yeah.
Was that a question? Or are you sure?
Yeah.
Okay, you're sure?
Yeah.
So after we get to this part, we multiply a times a together, and that's a squared, right?
Mm-hmm.
Good so far?
Yeah.
A times b is negative, a times negative b is negative ab, because negative times positive is negative. So that's right here.
Yeah.
Yeah?
Yeah.
A times negative b is negative ab. So that's right here.
Okay.
Yeah? And then negative b times negative b is b squared. So that's right here.
Okay.
And then, since this one is a negative ab and this one is also a negative ab, think about adding -1 plus -1. That's -2, right?
Yeah.
Yeah, so this is like a negative ab plus a negative ab. So you have two ab's, except they're negative because they're both negative. So like negative ab plus negative ab. That's
Oh.
it, plus -2ab, because there's two ab's and they're both negative, right?
Oh, okay. Yeah.
Does that make sense?
Yeah.
Okay, awesome. Any other questions?
No.
Okay, perfect.
You just stay for a moment.
What?
Just stay for a moment. I'm just gonna.
Yeah. I'll give you guys your practice problem. How about, actually, I write it down here. Let's do b minus 4 squared. Okay? Figure out what the answer would be when you multiply out b minus 4 squared. I'll give you guys like 2 minutes. Okay. Does anybody need more time on this one?
No.
Okay, who wants to explain it?
Can I?
Actually, let's let Apollo do it. Go ahead.
Okay.
Okay, so you could technically use a formula and then copy and paste it in. Like, okay.
Mm-hmm.
Like, can I see the entire thing? Okay. So since it says like it's A minus B times minus B, since B is in front, you could substitute A for B, and then since B is in the back, you substitute 4 for B.
Mm-hmm.
So then you just plug in everything in the procedures. Then after you do that, you get B to the power of 2 minus 2 times B times 4, 2B4 plus 4 to the power of 2. Then once you simplify it, you get B to the power of 2 minus 8B plus 16.
Yep. Awesome. Did anybody have any questions on that one? Okay. Awesome. We're going to move on. So now we're going to talk about factors and divisibility. Okay. So there's no better way
I
to
think
explain
your
this than by
screen lagged.
what?
I think your screen lagged. Never mind.
Okay. Can you guys see right now?
Yeah, now I can.
Okay, perfect. So, there's no like real way to explain factoring and divisibility rather than doing like going through a problem. So that's what we're gonna do. Basically what you're trying to figure out in if something is divisible by something, the best way to do it is just divide it and then see if it comes out to like a monomial, which if you guys remember is an algebraic expression with one term, right? So that's why I went over this in the beginning, just so that you guys had this background
And
knowledge.
3x is 1, so.
Yeah, so I'm gonna read through this problem and then show you guys how 24x to the fourth is divisible by 8x to the third. Okay, so the first thing you're going to do is find this. So you're going to divide 24x to the fourth divided by 8x to the third. So how to do that is simplify that. So what you can do is take out the coefficients. So 24 divided by 8 times x to the fourth divided by x to the third. Okay, so then 24 divided by 8 is 3. And then if you guys remember last week when we did dividing exponents, when you divide exponents, what can you do? Subtract them. So you can subtract 4 minus 3 since the base is the same. The base is x in both of these. Right. So you can subtract them and 4 minus 3 is 1.
And 3 times x equals 3x.
Yeah. And then you have 3 right here and x to the first or x from here. And that's what you see right here. And then you multiply them together and it's 3x. Now 3x is a monomial, right? As you guys learned before. And that's why 24x to the fourth is divisible by 8x to the third. Okay. So when you're trying to figure out if something is divisible by something else, when you divide those things like you see right here, this is what you're going to do. When you divide them, you have to get a monomial for it.
Can you just do 24 divided by 8 and then you get 3 and then you minus 4 minus 3 equals 1 and 3x?
Yeah, that's what you did right here.
Yeah, but I guess it's faster to say it.
Yeah, it is faster to say it. I just wanted to write out all the steps so that you guys aren't confused. So make sure if you're trying to figure out if something is divisible by something else, you need to have a monomial as your answer. So if it is a monomial, it is divisible. If it is not a monomial, it is not divisible. Okay? So you guys are going to do a practice problem. I'll leave this example up. So you're going to do right here at the bottom is 30x to the fourth divisible by 2x squared. Sorry.
Are we doing a practice problem?
Yeah, we are. It's this one at the bottom right here. Right here. I just wanted to leave this example up so that you guys can use it when you're solving. I'll give you guys one more minute.
Can you simplify the fractions?
Yes, you can.
Okay. What are we doing?
We're doing a practice problem right now.
You mean the 30x to the fourth divided by 2x the second?
Yeah.
Oh, okay. Do we just send you yes or no?
Yes, put it in the chat and direct chat to me.
When are we going to start explaining the problem?
Right now, who wants to explain what they got and how they got it?
Can I?
Yo-Yo, go ahead.
30x to the fourth is divisible by 2x to the second.
Yep.
30 is divisible by 2. 30x to the fourth equals to 30 times x to the fourth, and 2x to the second is 2 times x to the second. So 30 is divisible by 2, and x to the fourth is also divisible by x to the second. So it works.
Awesome. Yes, good job. Did anybody have any questions on that?
No.
Yep. Okay, perfect. Let me answer one in the chat really quick. Okay. Moving on, we're going to be talking about factoring trinomials, okay? This is the part where we're going to talk about quadratics. So quadratics is basically a quadratic is a polynomial that doesn't exceed the power of 2. So if you have like a to the power of 5 plus 5x plus 6, that's not a quadratic. If you have x to the power of 3 plus 5x plus 6, that's not a quadratic. A quadratic can, the highest power can be, is a 2. Right?
So it has to be like 3 to the 2 or 1 or
yeah, the highest it can be is a 2. So this right here is a quadratic. X squared plus 5x plus 6. Okay? So what we're going to do to factor trinomials is basically reverse the process of multiplying binomials. Okay, so up here, when we were multiplying binomials, up here, what we're going to do is basically take this and reverse it to find this. Okay, so how we're going to do that is by going through an example problem. So the first thing you're going to do if you're asked to factor this right here, the first thing that you're going to do is find two numbers that multiply to 6 and add to 5.
2 and 3.
Yeah. That's awesome that it came right to you. If that doesn't happen, what I like to do is make a list of all of the factors of this number. So the third number, I like to make a list of all the numbers that multiply out to that, and then think about which of those numbers that I've written down add up to this number. Okay, so I would write down 1 times 6 and 2 times 3, and then I would do, does 1 plus 6 add up to 5? No. Does 2 plus 3 add up to 5? Yes. Okay, so that's what you can do if you get stuck. Otherwise, if it comes right to you, that's awesome. So you're going to find those numbers. So that's 2 and 3, because 2 times 3 is 6, and 2 plus 3 is 5. Then you're going to add these numbers.
Basically, whatever x, basically, right?
Then you're going to add these numbers to x to form the binomial factors. So we have 2 and 3, right? So we're going to have x plus 2 and x plus 3. Okay? And that's basically it. So you factored x squared plus 5x plus 6. X squared plus 5x plus 6 can be factored into x plus 2 times x plus 3. Any questions?
Nope.
Okay, I'll leave this example up and you guys are going to do this practice problem and then you'll be done. So try this one and we'll go over it in like 2 minutes.
Wait, what problem? I don't see anything.
Right here at the bottom, you're going to factor x squared plus 7x plus 10. And then I left this example up here so that you guys can see it. Okay, we're gonna go over it because we only have 2 minutes left. So who wants
Can I
to
go?
explain? I'm gonna let Apollo do this one.
Oh.
It's okay.
Okay, so since 5 times 2 equals 10 and 5 plus 2 equals 7, so you're gonna use those two numbers. So it'd be x plus 5 times x plus 3.
Awesome. Any questions?
I mean x plus 2.
Yeah, I got you. Okay. That is all for this week. If you guys have any questions, don't be afraid to ask. I will post these notes on the Google Classroom and in the Google Drive. You guys have no homework this week, and I'll see you guys next time.